Uh, Hello, welcome back to the continuing lecture series in Principles of Finance. So today we are continuing the discussion about the uh, risk, a portfolio risk, how you minimize the risk through diversification, portfolio diversification. And so in our last class, um, we um, we finished off our class with the um, how the non-systematic uh, portion of the risk is diversified away, right, through well-diversified portfolio. And I said, um, when you uh, when you include about 15 to 20 uh, assets or stocks in your portfolio, right? Um, your total risk, overall risk goes down drastically, but what actually goes down is the that unsystematic part of the risk, and the systematic part doesn't go away through diversification. Now, here, another thing you need to remember about the diversification is that it's not just the number of the company, right? It's not the number of the company. It is actually the number of industries, right? Remember, the unsystematic risk is basically the risk, specific risks that are different industry by industry, right? And therefore, uh, if you have only 20 stocks in your portfolio, only in numbers and not diversified by the industry, but let's say you have 20 stocks from the same industry, 20 companies in the same industry, that doesn't help at all, right? It doesn't, it's not a diversification. Now, let me show you uh, an empirical evidence. Why? Uh, Different industries are, think about it. First of all, the companies in the same industry are highly correlated, right? In many aspects. Um, so, as an example, during the uh, this COVID-19 crisis, pandemic crisis, right? Uh, and I mentioned this in our last past couple of lectures that the travel and tourism, right? Travel and tourism industry is highly adversely affected by this crisis. Uh, Not just the travel and tourism, of course, most industries are, um, but IT industry is uh, relatively, not affected by the COVID-19 crisis. Um, and some companies are even, thriving. Um, and Pharmaceuticals, also thriving. Amazon is thriving. So, but then, hotels, restaurants, transportation, they are all suffering, right? So if you have, stocks from a single industry, you're not diversified at all. You're not, sufficiently insulated from the risk. So to insulate your position, investment position from the risk, you must diversify the industries. So let's take a look at this example. I want to show you You see what this is? This was back in 2006, 2000 through 2011. I've collected data of uh, I've collected data of like different two companies from each industry, right? And there were like eight or nine, uh, six industries uh, represented in this portfolio. So I picked two companies from, as I said, Apple and Google. They are what IT industries, right? And then Raytheon. Northrop and Raytheon are probably you've never heard of them because they are not consumer. They are not consumer goods. They are not in civilian consumer goods. They are all military. Uh, uh, they are defense industry, in other words. Northrop is a company that has been making fighter planes, from World War II and especially in the you know, uh, modern times, jet fighters, F5, F5 was already, 1960s, 1961, 60, something, 65. Uh, F5, F20, and Raytheon is a company that makes uh, smart bombs. Okay, it's not really something new anymore because the first time I heard of the name Raytheon was back in like 1990 when it was first Desert Storm, first Gulf War, and that was probably the first time that the missile hitting the target was televised on the TV on CNN because the missile is GPS guided and laser guided, and in the warhead of the missile there is a camera that broadcasts, as it lands on the target, right? It's finding its own target, and it lands on the target, and the camera is, actually broadcasting, its trajectory. I mean, so the viewers on TV were able to watch the missile actually, going, you know, towards its target, and then the screen goes off because, of course, the camera gets blown off, the minute it hits the target. Um, but that's why it was called smart bomb. But that was already 30-year-old technology. I mean, if you think about it, it's 2020 now. That was 1990, right? And you could see on CNN, right, a missile hitting the target, hitting its own target. So you've never heard of these companies, but they are obviously in defense industry, right? Some people might say, "Oh, that's devil's industry." Look, but it's inevitable. The military, you have to maintain a strong military to. It goes without saying, there is something called necessary evil, right? People say, um, no, you cannot be naive, Uh, about 20 years ago at BMCC, there was a discussion about, setting up a like a new program in security management or something like that, which would, and then that would not only be related to homeland security and then there was a huge uh, uh, protest against that program because some people were just so too naive. They all thought it was, I mean, their argument is, BMCC cannot sponsor a program that would you know, target that would aim at terrorizing. Look, uh, that is, if you think that is, that program is already, that was 20 years ago, and program never took off because of such a huge, protest. But you cannot think about a world that is only flowery, right? That's full of flowers and right? The world is not really like that, and it's inevitable. I mean, we don't want war, right? We don't want anything like that. We don't want any disease, but the fact is, there's disease, there's virus, there's cancer. Uh, we don't like war, but the enemies there are. It's also a fact that there are hostile enemies as well, sending terrorists. I mean, self-defense. What is wrong with self-defense, right? And if you think, you love peace, so you don't like any type of, military force or even, self-defense martial art, you are being too naive, simply too naive. How can you? I don't like guns. I'm a strong supporter of, gun control because I don't want the guns to end up in the hands of, the wrong people, and uh, most likely, uh, no one with military training, right? Or if you are not in the uniformed service, and if you're on active duty, and even if you're a military, if you're not on active duty, you have no right to possess a gun. Okay, the gun is for only, if you are a military, using it on your duty, right? For of national, military service, that is official use, but you cannot, right? It's absolutely, uh, you know, uh, illegitimate. It's illicit if you are carrying the gun that was, that is supposed to be for your, official purpose, right? Uh, and and carrying it into your civilian life, that is totally, outright violation of the code of, the conduct, right? So anyway, uh, but one thing, the reason I picked, this industry, defense industry is relatively, um, uh, counter-cyclical. Counter-cyclical meaning during the peacetime, uh, the defense industry, and I probably mentioned, this when we were talking about the municipal muni bonds, city of Bridgeport, right? Why they went bankrupt? Because during the peacetime, the military defense department, DoD contracts are getting slashed, right? Uh, Anyway, so think about it. We most of our stocks will be in our portfolio will be cyclical. But if all the stocks are cyclical, when the business economy goes up, your portfolio is all pulled up. But when it goes, they get pulled down altogether, and nothing is stopping that free fall, right? So you need to have something that is, counter-cyclical, right? And Merck, Pfizer, they are all pharmaceuticals. Walmart, Costco, consumer retail. J.P. Morgan, Citi, uh, what? Financial, right? Financial industries. CNS, that is real estate, right? CNS and Abacus, they are real estate management, right? And what are these numbers? So look at this. Look at the rows and columns. You would see that the rows and columns are basically repeating themselves. Apple, Google, Northrop Raytheon, Merck. What is that? Rows and columns represent, So basically, this cell, Apple and Apple, that's correlation, the correlation of Apple with itself. Now, think about it. Self-correlation. I mean, you and yourself, the correlation is one, right? Exactly. In other words, what is expected in this diagonal? Follow the diagonal, and you would notice that everything along the diagonal is one. What does that mean? Because it's uh, correlation with itself, right? But then look at this: Google and Apple. It's the correlation between Apple and Google, and they are in the same industry. I mean, not exactly the same, but uh, related industry, similar industry, right? And as expected, if you're in the same industry, what would be the correlation? Correlation would be high, relatively, right? I mean, one is the perfect correlation, right? -1 is perfectly opposite or perfectly inversely inverse correlation, right? So think of it this way. Uh, if you have a twin, right, even an identical twin, right, they are not perfect match. Their correlation is not one because even an identical twin, uh, there's some degree of differentiation. So, but an identical twin would be almost like 0.99, right? The correlation between the two would be 0.99. I'm only talking about the appearance, right? The outward appearance, right? In terms of, but then, um, and if you have, let's say, an evil twin, right? An evil twin, right? And uh, and personality-wise, character-wise, you and your evil twin will be like night and day completely. The correlation would be -1. If you like blue, he likes red. If you like white, he likes uh, uh, black. Or if the tastes are completely different. If you like coffee, he likes tea. Or if you like right. Um, so you can't agree at all. That's complete 100% inverse correlation. That would be -1, right? So look at these highlighted cells. Basically, I highlighted uh, the companies that are relatively uh, uh, little related. So the look, 0.1 to 0.1, 0.13, they are pretty much 0.05 to 1. This is very low correlation compared to like something like 0.723, right? So Abacus is a real estate management. Walmart uh, as a consumer, spending, right? Consumer retail. And if you think about it, the correlation would be very low because usually real estate management uh, doesn't suffer as much as the consumer retail during uh, an economic downturn, right? I mean, people still will have to live, need a place to live, pay rent. Uh, Whereas, if you are in a crisis, of course, the first thing that you would slash the food, budget, right? Uh, and then, look at the also Mark and Walmart, Raytheon and Walmart, consumer retail, and Pfizer. Merck is pharmaceutical, Raytheon defense industry, right? And then very low correlation. I mean, even if it is a Pfizer, but look at Walmart and Pfizer. Even if they are, Pfizer is pharmaceutical, but the correlation is not as low as correlation between Walmart and Pfizer is not as low as correlation with Merck. Why? Because compared to Pfizer, Merck is more, they are more, like you, even if it is a pharmaceutical, some of you probably haven't heard of Merck, because Merck is more into, they are making products, medications for fighting more, curing more severe disease, like, something like cancer, or, something that is being used on, like, hospital level, right? Clinical level. Whereas Pfizer, uh, very well known, something like, aspirin, or, ibuprofen, or something that, or, analgesics, something that are easily bought over the counter, right? That doesn't require prescription. Whereas Merck, most of the Merck's products require prescription. Anyway, but you can buy those things, like analgesics, or um, ibuprofen, uh, ibuprofen, or some, a prescription. But most of the over-the-counter, they are sold in Walmart, right? Makes sense. So that's why. Now, anyway, but this was the correlate. So when you construct a portfolio, you would want to construct a portfolio with the stocks of the companies that are little correlated, right, with the low correlation. And between the years 2006 through 2011, I mean, 2006 was pre-financial crisis period, right? But so this was the period, including pre-financial crisis through financial crisis. But this is, period including during the financial crisis, right? Because financial crisis was 2008, and the recession bottomed out officially by the data only 2010. And look at the change over time. You now see the companies that are negatively correlated. What does that mean? So if the correlation is -1, what does that mean? If company X goes up by 10%, then there's a company Y that goes down by 10%. Makes sense, right? So this is why the diversification completely wipes out, the risk of the, a non-systematic risk of the portfolio. Okay, so let's take a look at. So what does this? What does this tell you? What does this mean? What does this graph showing you? First of all, suppose you are picking a stock A. This is stock A, company A, and you see this is basically the variance from here. This is the this is the variation in the return, right? And this is the mean return. And I told you, this is when you put it along the timeline, right? If you ignore the timeline, this will look like, the normal distribution curve, right? Remember? It will look like this, right? If you just, ignore the timeline and look at, the variation in returns. But if you plot it along the timeline over time, it will look like this. And stock A, if you look at stock A And let's say this is following the business cycle. So stock A is a cyclical stock, and it has a wide variance, right? And this the wide variance is a risk, high risk, right? Because there will be a lot of fluctuation in. Now, ideally, if you can find stock B, which is perfectly negatively correlated with stock A, meaning correlation coefficient between the A and B is -1, but then it will move exactly in the opposite way. When stock A goes up, stock B goes down. When stock A reaches its maximum, highest point, stock B reaches its lowest point, and then as A goes down, right? Expansion, decline, expansion, shrink, um, contraction, right? Hitting the lowest point, and that's when stock B reaches the highest point, right? And then expansion again. Then stock B goes into contraction, right? Good. But what are the chances of actually finding something like stock B, right? This is just only a theoretical and a hypothetical situation. In reality, it may be it's unrealistic that you can find two stocks that are perfectly negatively correlated, right? And if they are perfectly negatively correlated, uh, your variations in return for stock A will be completely offset, right? Will be completely offset by the uh, variation in returns of stock B, right? That means, without any swing, without any variation, and if you construct a portfolio with A and B only, you will have constant, constant, you will have, uh, uh, unaffected uh, expected return, meaning unaffected by fluctuation in A and B. And this expected return is the portfolio expected return. In other words, you construct A and portfolio with 50% A, 50% B, and since they are in completely opposite lockstep, right? Um, this expected return will be maintained. The expected return of the portfolio will be maintained, but at zero risk because there is no standard deviation of this portfolio, right? Because they cancel out each other. But once again, as I said, it's unrealistic to find two stocks that are completely, inversely correlated. So then what do? But in reality, you may be able to find a stock that are positively correlated to some degree, right? Now, so you may be able to find something like stock C. And if stock C is perfectly positively correlated, it will move exactly like stock A, but it is not. So maybe the correlation is something like 0.5, right? Or 0.4, right? Then, uh, stock A goes ahead and, stock C is somewhat, like lagging behind, right? But anyway, if you can find a stock like C, right? You can find stock C, right? Uh, then, if you construct a portfolio with A and C, then actually the and their expected return of the portfolio is the same, but uh, the wild variation, the swing in the returns, will be much more tamed. In other words, it will return on the portfolio, the variance on the portfolio would look more like this. In other words, You see, this was like, without any uh, portfolio, right? Composition of, just stock A. But with, stock A and C, the portfolio return will, the variation in the portfolio return will be much more tamed, right? So that's why you are building a portfolio. And theoretically, okay, so I'm not, so then let's think about it. Correlation coefficient is actually, between A and B, stock A and B. Correlation is represented by a row, right? A Greek character row. Here's the mathematical thought experiment. First of all, what is the portfolio return? Portfolio return is the weighted average of individual stock return. Remember back here. Okay. What is the I don't know. There must be a lot of flickering in the. There might be a lot of flickering in the on the screen. I don't know. This is something that happens with the PowerPoint. But this is the portfolio return. Remember this example? You have three stocks in your portfolio: X, Y, and Z, right? And then their expected returns of each stock, and we determine the weight, right? So we decided to put 33% in X, 50% in Z, and so on. And what is the expected return on the portfolio? Is the weighted average, right? This times this, plus this times this, plus this times this, right? And then that's the portfolio return. Then you might wonder, also, then what's going to be the portfolio risk? In other words, the standard deviation of the portfolio. Well, you might also think, oh, wouldn't that be the weighted average? Yeah, but it's not that simple. It's not that simple. It's weighted. It's a kind of weighted average, but it's not that simple. Why? You might think, oh, so if you just multiply the weight of X by the standard deviation of X, and then plus weight of Y and standard deviation of Y. No, it's not that simple. Why? First of all, you cannot have standard deviation without variance. I mean, you remember when we calculated standard deviation, we started out with the variance. So think about it. So let's assume, so standard deviation of portfolio, a variance of the portfolio is, this is the way you can write variance. Why? Remember, sigma is the, symbol for standard deviation, and this subscript P stands for portfolio. So it's the standard deviation of portfolio. But then squared, what does that mean? Standard deviation squared is the variance, right? So how do you find the variance of the portfolio? Well, then it's weight of X times standard deviation of X plus weight of Y times standard deviation of Y. And you might think, oh, that must be the standard deviation of portfolio. No, you have to first, find variance, right? So this is basically, then variance of the portfolio. And then we will need to expand it, right? Why do we do it this way? Because can we not just add up this and this? No. Why? Because between x and y there would be some correlation. X and y are not uh, uh, perfect. I mean, if there is zero correlation, right, between x and y, you can do just this, right? Zero correlation means, but all the every industry is in to some extent uh, is correlated with one another, to a greater or to a lesser degree. So because of the correlation between the two, you cannot simply add them up like that. We need to factor in the correlation. So, and there are, interactions between the two industries, right? So, how do we expand it? You probably learned this in, very, intermediate elementary algebra, right? This is something you will learn in, like, seventh grade. So x plus y squared is what? X squared plus 2xy plus y squared. Isn't that right? Yes. And what is, 2xy? X times y is the, intersection between x and y. In other words, there is a, um, the intervening effect, right, between each other, right? And as long as x and y are random variables, so there is a correlation between the two. So if x and y are not random variables, you just do it like that. But if x and y are random variables, then we have to factor in the correlation between x and y. This is Greek character rho. Of course, rho would stand for correlation, right? Rho, the correlation between x and y. So actually, to correlate rho xy, correlation between x and y, is defined this way. If you did statistics, you would. It's the covariance between x and y and standard deviation of x and times standard deviation of y. Now, and the correlation, we know it's between -1 and 1, right? 0 being no correlation whatsoever. So let's assume that the weight in each asset, x and y, weight and are both 50%, 0.5, 0.5. And let's say standard deviation between the two is also standard deviation of x is 0.5, standard deviation of y is 0.5. I'm just to that, Then, if we expand it, then it's going to be, and also assume further, correlation coefficient is 0.5, right? What a wonderful, correlation coefficient is -1. Correlation coefficient is -1, meaning, x and y are perfectly inversely correlated. When x goes up 10%, y goes down by exactly 10%. X goes down by 20%, y goes up by exactly 20%. So if that's the case, right, let's think about it. If we expand it, right, let's do that. Weight of x squared is 0.25. Why? Because it's 0.5 times 0.5, right? 0.5 times 0.5 is 0.25. And this is also 0.25, standard deviation of x, right? So 0.25 times 0.25, so 0.25 squared. And then plus 2 times 0.5 times 0.5, so 0.25, right? Times 0.5 times 0.5. So what's that? 0.25. So it's all 0.25 squared. And then this is -1. So what does that mean? This becomes -2, right? This becomes, I mean, this becomes, negative, uh, negative, uh, 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 negative 0.25 squared. And because it's times 2, it's going to be 2 times negative 2 times 0.25 squared. I mean, this whole thing. And then finally, a weight of y squared, 0.25, standard deviation of y squared, 0.25. So what do you see? This and this is 2 times 0.25 squared, isn't it right? And then this is uh, negative 2 times 0.25 squared. So what happens? They cancel out each other. They perfectly cancel out each other, right? Then the variance of the portfolio becomes 0. That means, that's why if you construct a portfolio with perfectly negatively correlated and under, this restrictive assumption, their weights are the same, weights are 0.5, 0.5, standard deviation 0.5, then they will perfectly, cancel out each other. So that means you will you get the expected return with no variation, no in uh, distribution of returns. It's going to be always, right? So this is basically the role of the correlation coefficient. Okay, makes sense. So therefore, that explains. Now, that's why it makes our portfolio diversify away the non-systematic risk part of our portfolio. And then um, but then what about the systematic risk part? I mean, it doesn't get diversified away. So what do you do? What do you need to do? Well, then, since we cannot diversify away the systematic risks, then we will have to exploit the because it is coming from the systematic risk is coming from the macroeconomic system and the financial market. We will need to react accordingly to how the market moves. So we need to find the correlation between the stock market and individual stock, right? And then the correlate, you just heard, oh, the correlation is measured by a row. Uh, uh, yes, that's between. It's a little different story. That's between the random variables, right? In individual stocks, but when it is between the market and individual stocks, the correlation is measured by beta. Okay, beta is like alpha beta, right? And beta is basically beta is the slope coefficient in a linear function. Okay, they say beta measures the market risk or the volatility, right? That means how much how much co- uh, how much correlation is there between this particular individual stock X and the market? And if the correlation between the market and the stock is 2, that means when market goes up by 10%, the stock goes up by 20%. When market goes down by 10%, the stock goes down by 20%. And if the beta, the correlation between the market and the stock is, if that is 2, and if it is -2, then the opposite happens, right? When market goes up by 10%, the stock goes down by 20%, and vice versa. But then, so I said before, I explained that if a stock has a wide variance, that means it's more stock is more volatile. But at the time, I told you there is a actually uh, strictly it is different. Volatility and the variance is different. And I explained at the time when we discussed the variance that they use the word interchangeably. They use as if they confused these two words, the variance and the volatility, as if in actually everyday language, I mean, it's in stock market language, they use the term volatility actually to mean variance, right? And they are using it in confusion. Why? Actually, volatility is part of the that variance that is due to the correlation with the market. Okay, but you understand the variance is not. If you're looking at the variance of the individual stock, right? Then you can separate the part of the variance that comes from the correlation with the market and the other part, non-systematic risk, that can be diversified away. But but when you construct a portfolio, and if the portfolio is well constructed, meaning all the non-systematic risk is diversified away, then the only risk remaining is the systematic risk. So then you can say the variance is mainly due to volatility. So you can use the term interchangeably. But unless that's the case, it's not right to equate these two words. Okay. Now, but why is it called beta, and how is it different from rho? Now, in this one lecture, I'm trying to cram in as much. This is more advanced, um, uh, more advanced topic, but it's just 1 hour session. But I have to cram everything into this 1 hour, which should normally be covered over like many hours, like at least 3 to 4 hours. So that's very difficult. But bear with me, because we are at the end of the semester, and this is the practically the last lecture of the semester. So it might be a little a longer session. Now, why beta? You remember beta is the slope coefficient in a linear function. What's a linear function? You remember, you probably did this type of exercise in middle school, right? This is a graph of y equals 3.5 x. In other words, this is a linear function, because what does that mean? Linear function means whatever whatever value x takes, right? Y is determined by the coefficient between x and y and the x value. That means, what is this? This is the correlation coefficient between x and y. And the correlation coefficient means, if x is 1, y will be 3.5. If x is 2, y will be 7. X is 3, y will be 3 point, whatever, right? That will be 10.5, something like that. X is 5, you can. So in other words, y value depends on the coefficient and correlation coefficient and x. In other words, the correlation between x and y is whatever happens to x, 3.5 times x will happen to y, right? Makes sense? That's what, and this correlation is runs only one direction. It's unidirectional, one direction. It runs only one direction. Meaning the correlation runs from x to y, not the other way around, right? Makes sense? So this is the difference between beta and rho. In rho, uh, if the correlation between x and y is 3.5, the direction can be both ways, right? X can be 3.5 times y can be, I mean, it runs both ways, right? It runs both ways. Correlation is both ways, right? Um, uh, but in this case, so in other words, um, X, that's why in this case, X is the independent variable. X varies independently, right? It doesn't depend, change in X doesn't depend on Y. But Y is called a dependent variable because a change in Y is caused only by change in X. Make sense? It's almost like, change in X causing change in Y, right? And then think about it. Then if X is 0, Y is also 0, right? Um, and this exercise, through this exercise, you would know that all these coordinates, right, between X and Y, fall nicely and neatly on a straight line. If, in other words, if you connect these dots, right, it is exactly a straight line, right? Makes sense? Starting from the origin, right, going through the origin. But is that the reality? No, that's not the reality, right? That's not the reality. Why? What does that? In other words, in this case, this correlation coefficient was pre-given, right? So it was already given, 3.5 was given. Then x is given, so all you need to do is just plug x into this linear function, right? It's called linear function. It's a function in line format, right? Linear. It just goes linear. So uh, you put $1 into it, and $3.5 come out. You put $2, $7 come out, right? It is because in this example, and this is what you at least I did in middle school, right? I was uh, like seventh grade, right? That was very, very uh, uh, elementary algebra. But it is, once again, so it is very artificial. Artificial. What that means is, uh, the correlation was already given. It was predetermined correlation. And then according to this correlation, everything will fall neatly on a straight line. But that's not the reality. What is the reality? Um, Reality is more like this. In other words, nobody knows what the correlation coefficient is. It's not given, right? It's not given at the beginning. It's not given to begin with. In reality, what you see to understand the correlation is starting from the coordinates between stock X and stock M. M is what? M is the market. M stands for the market, right? In other words, the average return on the market. And X is an individual stock. Remember, and the horizontal axis is the independent variable, right? And the vertical axis is the dependent variable. And if you think about it, between the market return, average return on the market, and the individual stocks return, which one is independent variable and which one is dependent variable? Hmm? Don't you think Isn't that the market? Isn't it obvious? Why? Individual stock cannot affect the market, right? No matter during a like severe recession and economic downturn, just because Apple does well, individual stock Apple may do well, Amazon may do well, but just because an individual company does well, extremely well, Amazon is doing extremely well, it cannot pull up the entire market, right? But when market falls altogether, when the market crashes, as a whole, almost every individual stock is also adversely affected, and they are being pulled down too. You cannot, when the market goes down, you cannot, as a whole, there is not a single stock that can resist, right? Of course, when, as I told you, there may be a stock that is negatively correlated with the market, and I told you it's called countercyclical stock, right? And a countercyclical stock may move in the opposite direction. Okay, so this is once again another way of I mean, between individual stocks, yeah, you can minimize, by diversifying because the correlations, different correlations would like cancel out the variation in the portfolio. Now, uh, but still systematic risk remains. What about the systematic? Uh, and the measure of the correlation with systematic correlation is beta. So that means if you construct a portfolio with varying degrees of beta, right, then at least you can tame, right, the volatility. Meaning, you can tame the fluctuation or the variation stemming from the correlation with the market, right? Makes sense. So then question is, this line isn't given. Think about it. Nobody, you are given. I mean, when you have a data, right, and you plot. This is called basically scatter plot. Why? Because you plot the this data. In other words, what does this dot mean? That means when market return is this level, right? Uh, what is the stock X's return? Stock X's return is this level. That's what it means, right? All of these dots are coordinates between market's return and uh, the individual stock's return. Okay. So um, I was hoping to be able to cram it within 1 hour, but it seems like it's going to take longer than an hour. So maybe at some point I will uh, stop the video and uh, maybe put additional smaller video, like maybe 30 minutes. Maybe but then let me do this. Let me take care of. Actually, I'm recording this in the middle of a class, so okay. Let me do this. So okay, let me wrap this. Let me cut the video here and let me stop start a new video because the file size is getting too large and it's going to be very difficult to upload. Okay, I'll see you guys in the next class. Okay, or next segment of the video. Okay, stop recording.